today, sir, this is my performance task number 7. To start with, what is CPU? It is often called the brain of the computer. It sits at the center of everything in the computer and handles all the computation. They are the general purpose, flexible architecture that take in a stream of instructions from all type of workloads. Processes information based on those instructions. Proceeding in the history of computer, our computer is fragile, slow, and large. Way back in 1945, where the birth of digital computing occurred. So as the time goes by, our computer technology evolves more. ENIAC, the first general-purpose digital computer from 1946, covered 1,800 square feet, or the size of a modern home, and weighed about 30 tons. So ENIAC stands for Electronic Numerical Integrator and Computer. History of CPU. There are some people who improved our CPU. The first one is the Gordon Moore. He invented the Moore's Law in 1965, and he developed the transistor in a dense integrated circuit, and it doubles about every 2 months. The next one is John von Neumann. He's a prominent mathematician in the late 1940s, and he invented a CPU architecture, popularized new kind of computer architecture that simplified computer design and programming. And the other one is Robert Noyce in the late 1959s. He patented the first monolithic integrated circuit, which combined multiple transistors on a single silicon chip. The CPU functions as many different types of operations, where the first one is fetch, decode, execute, and store. Fetching instructions from the memory, decoding the instructions, and the executing the instructions, and lastly the storing results back in the memory. The evolution of Intel was first released in 1971, which is the Intel 4004. Then in 1972, the Intel 8008. Next is in 1974 released Intel 8080. In 1976, it is Zilog Z80, and in 1978, Intel 8086, and then the 11th gen Intel Core processor named Tiger Lake. Proceeding in the computing abstraction layers, there are 3 couple of concepts that are key to understand with regards to computer architecture. Number 1 is the binary system, and number 2 is computing abstraction layers. Digital computers use a number system based on 0 and 1s, or binary system. There is a great power in what the binary system allows us to do by representing data as a series of on or off states in computer or memory. ISA, or instruction set architecture, is an abstract model of the computer, sometimes also referred to as architecture or computer architecture. It describes the memory model, supported data types, registers, and behavior of the machine code. It acts like a sort of bridge between software and hardware. Speculative execution. When a microprocessor executes newer instructions than a branch without knowing if that branch is taken or not. It is the fundamental component in modern microprocessor for achieving great performance. And this is the table for speculative execution. Superscalar execution. It is the simplest form of execution wherein arithmetic logic unit, or ALU, performs adds and subtracts. When ALU operates in parallel unit, this is where superscalar execution is. It is also a CPU that implements a form of parallelism called instruction level parallelism within a single processor. And lastly, we may not realize it yet, but we are surrounded by CPUs and computation they perform for us. They have an impact on every element of our existence. CPUs are omnipresent and influence almost everything we do. So this is the end of my report.